Hello and welcome to step 16. So step 16 says, I can apply the definition of congruence in terms of rigid motion to triangles. So in the book, this is chapter 4, sections 3 and 4, and there's one small postulate that I also pulled from 4-5 called hypotenuse leg that we'll cover. So I'm going to go back for just a second. You stay where you're at. So back in step 15, we talked about congruent polygons. So in order to prove if two polygons are congruent, we had to prove that every angle has a corresponding congruent angle and every side has a corresponding congruent side. Once we prove that all of the angles matched up with another angle and all the sides matched up with another side, we could say that they were congruent and we could write what we call a congruence statement. So what we're going to do today is we're going to prove that two triangles are congruent, but we don't have to prove everything anymore. We'll have to prove 3 things. So the first shortcut that we'll talk about today, so we're going to talk about 2 in this first video. The first one is called SSS. S stands for side. Okay, so this is called the side, or SSS congruence. Okay, so this holds true if we're trying to prove if 2 triangles are congruent. So if we can just prove that the 3 sides have a corresponding congruent side, then the triangle is congruent. Okay, we don't have to say anything about the angles. If we have something about one of the angles, great. But really, if we just prove that the 3 sides match up with the other 3 sides, then the 2 triangles have to be congruent. And this only holds true for triangles. Okay, you can't prove like 3 sides of a rectangle or a hexagon match up on the other side. These postulates are only for triangles. So I tried to start out super simple for us. I already wrote out all the statements for our 2-column proof. We just have to figure out the reasons. So just to go back on how we write a 2-column proof, we always start with the given. Okay, so if you want to make a little note for yourself, this is what you start with, and this is what you end with. Okay, so notice our very first line is exactly the given. So our reason is just this is given. And notice our very last statement is what it tells us to prove. The triangle GHL is congruent to triangle KJL. And we're not going to write that this means prove. We just know that that should be our last statement. So the first thing I want you to do is always write the given first, and then I want you to actually label it. So remember, if we have segments congruent, we label it with those like little tick marks. If we have angles, we do the little arcs. So let's look and make sure, okay, we have our given written down, and then we're going to label it. So GH, one tick mark, is congruent to KJ, one tick mark, and then HL is congruent, so I've already used 1 tick mark, so let's use 2, and then JL. And then L is the midpoint of GK. Okay, so one little trick just before we get any further is as you go through a statement and a reason, it might help to label in that line what did you actually find. So GH congruent to KJ, that shows us that we have a set of segments or a side. So maybe out here I can put an S because I know I have a side in that line. And then I have HL is congruent to JL, and that's another side. So in this line, I've already established that 2 sets of sides are congruent to 2 other sides in the other triangle. Okay, and then I have something that says L is the midpoint of GK. It doesn't really help us. That doesn't tell us anything's congruent. We don't have side congruent to side or angle congruent to angle, so we can't label anything. If we look at statement number 2, it says GL is congruent to KL. So I have GL is congruent to KL. Okay. Now we have to figure out the reason. The reason is not the given because we've already listed all the given. They're not the same, so that's not reflexive property. But if I go back to my given, it says that L, so this point here, is the midpoint of our whole segment JK. Remember, this word midpoint means right in the middle, okay? Like if you were going to mark the midpoint of a candy bar, you're going to put it right in the middle and cut it exactly in half and make two equal spots. So for this reason, I'm going to be a little lenient. You can say two things. You can say either midpoint theorem, or if you said maybe like definition of midpoint, just something so that I know that you're acknowledging that that's a midpoint. Okay, and that would be another side for us. So we have in the first statement 2 sets of sides. In the last statement we have 1 set of sides. So we're going to call this, the only shortcut that we know is just side, side, side. Okay, we didn't have to prove any of the angles. We're not using third angles theorem or anything like that. We proved that the 3 sides in one triangle are congruent to the 3 corresponding sides in the other. So they are congruent. Okay, let's look quickly. This one I think should go a little faster since we just did one, and we're kind of getting the hang again about how to do 2-column proofs. So remember, first thing, we always list our given. Hopefully, maybe you even already wrote that down. Okay, so we have our given, and then we are going to label. Remember, we're only labeling things if it actually has a congruent statement, meaning it actually says that this is congruent to that. So it says QRS is isosceles with QR congruent to SR. So we have that congruent statement, so we can mark QR is congruent to SR. And it says RT bisects QS at point T. Okay, so we don't have a congruent statement there, so we can't say anything, but we definitely in this first one have a side because QR is congruent to SR. I put number 2 and number 3 in the same color because they go together. The number 2 says T is the midpoint of QS. Okay, and you're probably thinking, well, how do we know T is the midpoint of QS? Well, the only definition of midpoint that we know is that a midpoint is exactly in the middle. So if we look back at our given, okay, it says RT bisects QS at point T. If we bisect something, we cut it exactly in half, just like a midpoint does, okay? When we like if I gave you a cake and I said bisect it, you would cut it exactly in half. So we know that T is the midpoint. This is kind of an extra step that you don't necessarily need to have, but we're going to put it in there just to kind of review some vocab. So we know T is the midpoint because we know what this bisects means, okay? And we have 2 types of bisectors. One is a segment bisector and one is an angle bisector. This is going to be a segment bisector. So we're just going to write definition of segment bisector. Okay, and then we had QT is congruent to ST. We have that congruent statement, so we can go ahead and mark those. And we know that those are congruent because we've established that T is the midpoint. Okay, so I'm going to use midpoint theorem, or if you put definition of midpoint, that would work as well. We have another congruent statement, so I'm going to label that as a side, just to remind myself. And then last but not least, RT is congruent to RT. So the same segment is congruent to itself. Anytime anything is congruent to itself, this is what we call reflexive property. then we have another side. We have 3 things, which is great. And it would be side, side, side. All right, this next one I just want to talk about. We're not actually going to fully solve, but if we wanted to prove that 2 triangles were congruent to each other if in the coordinate plane, you may come across this on the state test, but we're not going to spend the time with it because it's few and far between. So if you had something like this, the first thing you obviously would want to do would be to graph it. That's why I have this coordinate plane here. The next thing, once you have them both set up, you might be able to see that they have a matching angle or they have a matching side, which would already give you something to use. If you wanted to prove that the sides were congruent, but you didn't know, like they didn't match up like reflexive property, you would just use distance formula. So use distance formula to find side lengths. So the reason things are congruent is because their measurement is the exact same. So if we found all of the side lengths and they all matched up to something else, then they would have to be congruent. Okay, the other shortcut we're going to talk about is called side angle side. This is probably my favorite shortcut. It comes up a lot. It's one of the most commonly used shortcuts. Obviously, side, 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 we had to have 3 congruent sides. Side angle side, we're going to have 2 sides and an angle. Oops. And the only tricky part about this one is that where that angle has to be is sandwiched in between those 2 sides. So notice this angle here is in the middle of the 2 angles we've marked congruent. So B and E fall between these 2 sides that we've said are congruent. So like it would go green, then angle, blue, and then side purple. Same thing with the other one. So side, and then that angle, and then the other side. So that the angle that the 2 sides create, you could say is congruent as well. Okay, so if we look, again, I gave you the statements. We're just going to try to figure out the reasons. So it says the scaffolding for the stage lighting shown appears to be made up of congruent triangles. We know that WX is congruent to YZ and WX is parallel to ZY. So that's our given. Already written that out for you. And then it says prove that those 2 triangles are congruent. Okay. So the first thing I want you to do is let's label the fact that those lines are parallel. Remember, we label that lines are parallel by 2 little arrows. So I'm going to label WX. So this top line up here is parallel to ZY. Okay, so we got that labeled. Let's label our other piece of the given. The same 2 lines are actually congruent to each other. So the top and the bottom, those 2 are congruent. All right, next thing, WXZ. So I'm going to go ahead and highlight these. I'm trying to think because this picture is not very big. Let's see, WXZ. So remember, when we label it, we start at W, we go over to X, and we go down to Z. So our angle would be right here. And then XZY would be would be right there. Okay. So just to speed up the video a little bit, we have parallel lines. So if I follow parallel line, angle, parallel line, we create a nice Z for ourselves. It's backwards, I know, but it still is. No, it's not backwards, duh. it's still a Z, and those angles that get caught in the pockets of the Z are called alternate interior angles. And they are congruent. Number 3, XZ is congruent to ZX. That's the same exact segment. So this would be reflexive property. Okay, so if I go back in our given, we had a side. In number 2, we had an angle. And then in 3, we had another side. So for our congruence, we would have side, angle, side. Just a quick tidbit. If you're going to use side, angle, side, you don't have to label them in order. You don't have to say one side, then the angle, then the other side. You can label side, side, angle, or angle, side, side. That's fine. You just need to look back at your picture and see, okay, our black tick marks, we had a side, and then if we start rotating around our triangle, we have another set of angles, and then we have another set of sides. So we had side, angle, side. Excuse me, do not have to put them in the order of the segment. The biggest thing is that once you label your 3 things and you're trying to figure out which theorem it is, you are not allowed to spell the bad word, okay? So for like this example, you are not, never, ever allowed to use SSA, big no-no. And if we flip that, that's the bad word. So you would never spell a bad word with these shortcuts. So this would have to be side, angle, side. Okay. Let's do 5 really fast, just so you have this example finished. So number 1 is obviously our given. Okay, let's make sure it's labeled. We have FG is congruent to GH. That's labeled, but let's just mark it a little darker for ourselves and say that this is the side. And then JG bisects angle FGH, which doesn't tell us it's not congruent, so we can't mark it. So number 2, FGJ, F to G to J. You see that for the most part. And then HGJ, congruent. Okay, so obviously something's happening at G because we've marked the 2 smaller angles at G on either side. So if we go back to our given, it says that JG bisects angle FGH. Okay, remember if it bisects, it splits it exactly in half. So this would be definition of angle bisector. And then last but not least, I'll do this in a different color instead of blue. GJ is congruent to itself. So that would be reflexive. Oh, not pretty. Okay, so number 2 was an angle. Number 3 was a side. So we have 2 sides and an angle. We're not going to spell the bad word, so we're going to put A in the middle. So this would be side, angle, side. Okay. Oh, sorry, I forgot. We have one last thing to go over. We don't really have to go over the proof, but you can. This would be given ln congruent to ln without even looking at the picture. We can say this is reflexive. And then I don't even remember why these are congruent. Oh, we would have side, side, side. So side, side, side. Okay, the last thing is, notice that the only reason I really wanted to do this proof was, notice we have our given listed first, but our proof statement does not say triangle congruent to triangle. Okay, we've already proven with side, side, side that these two triangles are congruent. And then we have this added step. Okay, any time you have this added step where you're not ending on triangle congruent to triangle. So basically, since we've used side, 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 we haven't proven anything about the angles, right? We've proved all three sets of sides have a corresponding congruent side, but we haven't said anything about the angles. But now that we've established, hey, we knew all the sides were congruent, the triangles are congruent, therefore everything else that we have not named yet also has to be congruent because we know the triangles are congruent. This is what we call CPCTC. Okay, and I'll write it out right here. So CPCTC means that corresponding parts of congruent triangles are congruent. Okay, so this is going to be used anytime we have an extra statement following this congruent statement. So notice, we had something congruent, or the triangle congruent to triangle, and then we had this extra statement. Anytime we have an extra statement after the congruent triangle statement, we use CPCTC. Okay? And that is part 1 of step 16.